Our next lesson is going to cover acid and base nomenclature, which is to say how to name them. Previously, we talked about the characteristics of acids and bases and what an Arrhenius acid and base is versus a Bronsted-Lowry acid and base. You will definitely want to have your ion sheet handy for this section. Okay, when it comes to naming acids, there are two types of acids. There are binary acids and oxyacids. So to name a binary acid, here are the rules. So it has to contain hydrogen and one other element. So it's usually just hydrogen and one other thing. The rules are the first word has the prefix hydro to the name of the hydrogen part of the compound, and the rest of the first word consists of the form of the root of the second element plus the suffix -ic, and then the second word is acid. So this example down here, HCl, if we follow this, it's going to start with the prefix hydro. And then the rest of the first word consists of the form of the root of the second element. Well, Cl is chlorine, so that's going to be chlor plus the suffix -ic. The second word is always acid. HCl is hydrochloric acid. Now, many of you probably already have heard of that before, but it follows this naming system. Okay, it's not just randomly named hydrochloric acid. It follows these rules. So if we try this other one here, HBr, that is a binary acid. It's hydrogen, one other thing. Starts with the prefix hydro. Bromine is Br, so brome, and the suffix will be -ic. And then acid, that is hydrobromic acid. Okay, and be careful. We'll see here in a few minutes the oxyacid naming. Don't just stick hydro in front of everything that's an acid. That's not how to name them. This is just for binary acids. There are some ones to watch out for. We can have, say, hydrogen with multiple other elements that will follow the binary acid naming. The trick here is to know that the anion, to say the negative ion here, should always not include oxygen, should never have oxygen in it. So this one, HCN, there's no oxygen in this anion. Okay, that CN is just a cyanide ion, CN with a -1 charge there. So this is still going to follow the binary naming rules. So we got a cyanide ion. This is going to be hydro. And then instead of the root of the second element, because there's multiple elements here, it's the ion. So the root is cyan. The suffix is still -ic, and then acid. So putting that all together, that is hydrocyanic acid. So just be careful with that. Basically, if you see oxygen, you're going to use the oxyacid naming rules, which we'll see here in just a moment. If you don't see any oxygen and it starts with a hydrogen, then you're probably going to use binary naming. That is one more thing I should mention in case it hasn't been clear to you yet. Anything that starts with an H is going to be an acid, okay, maybe with the exception of water with H2O. But anything you see here listed with a name this acid or base, anything that starts with an H is going to be an acid. Okay, naming system number 2 for acids is if the acid is an oxyacid. So this is simply an acid that contains both hydrogen and an oxyanion, so it's a negatively charged ion with oxygen in it. It's called an oxyacid. Okay, so you can have oxyanions, right? These are things like perchlorate, chlorate, nitrate, nitrite. Notice it's got oxygen in it, right? Multiple oxygens in this case, okay? You can't just have one. If it's like a hypochlorite, that's fine too. So the rules here for this one, identify the oxyanion present. The first word consists of the root of the oxyanion, and the prefix is per hypo if they're included. The suffix depends on the oxyanion suffix. If it ends in -ate, the new suffix is -ic. If it ends in -ite, the new suffix is -us, and then the second word is always acid. Kind of down at the bottom here, I'm out of room, so I'm going to do the examples up top. We have HNO3 and HNO2. So following the rules here, identify the oxyanion present. What I generally like to do, once I identify it's an oxyacid, because we've got oxygen in it, it starts with hydrogen, I usually just split that hydrogen off because it's not really going to matter. What we care about now is this, and this is where you're going to go to your ion sheet. We have an NO3 ion here. That is a nitrate ion. Okay, so we're going to take the root of that, NITR, and we're going to change the suffix. If the suffix was -ate, the new suffix is -ic. If the suffix was previously -ite, the new one is -us. Well, it was -ate, So our new suffix is ic, and HNO3 is nitric acid, which you might have heard of before. Okay. Other example here, HNO2. It's an oxyacid because it's got oxygen in it. Starts with a hydrogen. Split the hydrogen off. Identify what this ion is on your ion sheet. NO2 is a nitrite ion. So when we turn that into an acid, we take the root still, NITR, and the suffix that was ite, okay, is going to change to us. And so NO2 is going to become nitrous acid. Okay, notice there is no prefix here for hydro. Okay, I get a lot of times where students will write like hydronitric acid. Don't do that, right? Hydro is just for binary naming, okay? For oxyacids, you use the root of the ion and then change the ate to ic or ite to us. As always, here are some notable exceptions. H2SO4, so this would be an oxyacid, right? Because it's got oxygen in it. It starts with a hydrogen. If we split the hydrogen off, this is a sulfate ion, SO4, -2 charge. Okay, that is sulfate. Now, you might think that the 8 here, right, changing to ic, it looks like it would just become sulfic acid. That's not correct. What actually happens, it's very similar. It's close. This is sulfuric acid, which you might have heard of before. That stuff's in car batteries. Okay. Similarly here, H2SO3, oxyacid. This is a sulfite ion. Okay. And you would think that maybe this would just become sulfus. Don't do that. That's not correct. The correct one here is sulfurous, kind of like its older brother up here, sulfuric acid, right? This is sulfurous acid. All right. H3PO4, split off the hydrogen. PO4, it's got a -3 charge. That is a phosphate ion. And you might think that that changed to phosphic, which is not correct. You've probably heard of this one before. This is phosphoric acid. It stuff's in Coca-Cola. If you go grab a can of Coke and look on the side of ingredients, it'll probably say phosphoric acid on it. This bottom one is included because you have to watch out for these. This can pop up occasionally. If something ends in COOH, it is an acid. And you have to be careful because this OH here makes guys oftentimes think that this is hydroxide. But if something ends with COOH, it's actually a special type of acid called an organic acid because it's got carbon based over here. So just be careful with that. This is not a base. This actually comes from there's nothing different about the name. I'm just pointing this out because this comes from an acetate ion, which is CH3COO. Like that. Comes from an acetate ion. This is acetic acid. Okay, with an 8 changing to ic. That is vinegar. Okay, one of the thing that gives vinegar its distinct smell and taste is acetic acid. So just be careful with that one. I'm pointing it out not because the name change is different, because we will have this COOH here, which is an organic acid. Okay, the good news is acids have 2 types of naming systems. Bases, you use the same naming system that you learned previously last semester. Nothing is different about it. You use the exact same naming system. And there's really only 2 types. Bases that have hydroxides and then other compounds that can make a solution basic. And hydroxides, you're really just going to use the rules from last semester when it comes to forming ionic compounds, because that's really what this is. Okay? You're just using the ionic compound naming system. That's it. If the compound is soluble and contains a hydroxide ion, then the name of the compound follows the formula name the metal plus the word hydroxide. Okay, this is very simple. NaOH is sodium hydroxide. Name the metal, name the anion, which is hydroxide. CaOH2, Ca is calcium hydroxide, right? Very simple. Okay, you guys will like naming hydroxides. Those are pretty straightforward, and they're easy to identify because they have a very clear OH in them. Just be careful it's not that COOH like an organic acid. If it doesn't have hydroxide in it, just follow the other naming rules from last semester. Okay, NH3, you might remember, has the name ammonia. It's the common name of it. You could also call this nitrogen trihydride with its technical name. Okay, either one of those will work. And this bottom one here is an ionic compound. This is calcium carbonate. So all you got to do is just use the old ionic naming system. Nothing's different about it. So bases are really nice because there's nothing different. Acids, you have to be careful. You have to identify, is it a binary acid or an oxyacid, and then apply the correct naming system to it. Here's kind of a nice flow chart to help you organize as to what you should do. All right, the first question you should ask yourself is the substance an acid or a base? If it's an acid, then your next question is, does it contain oxygen? The answer to that is no. Use the binary naming rules, right? Those are the ones that go hydro something ic acid, right? So hydro something ic acid. Okay. If it does contain oxygen, then look up the oxyanion name, okay, and go from there and follow those rules. If your substance is a base, it's really easy. Just follow the traditional naming rules that you already know. This is just kind of a nice flow chart, organizing everything for you in case you're not sure which direction to go with each problem. Go ahead and try these three and see how you do. And here are your solutions. This should be hydrofluoric acid, which is a binary acid, right? Hydrogen plus one other thing. Nitrous acid, so this is an oxyacid. It's got oxygen in it. This has got OH in it, so this would be sodium hydroxide. That's a base. Go ahead and give these ones a try as well. This is going backwards, so make sure you've got your ion sheet to help you out here. Okay. Don't forget that hydrogen forms a +1 charge, okay, when it comes to forming acid. So give these a try. It's a little trickier going backwards, and let's see how you do. Okay, so chlorous acid, there's no hydro in front, so that should tell you that this is an oxyacid. The OUS in it should tell you that it came from ite previously. So then you would go to your ion sheet and find a chlorite ion, which is ClO2 with a -1 charge. So the formula should be HClO2. Hydroiodic acid, well, hydro means it is a binary acid. And iodic is coming from iodine. So this is just HI. Okay, hydroiodic acid is HI. And then lithium hydroxide. Lithium's a +1 charge. Hydroxide's a -1 charge. That is just LiOH. So hopefully you did well on those.